Oh, hello, grade 10s. In today's lesson, we're going to be looking at pulses and waves approaching exam type questions. And let's go. Now we have question 6. It says the diagram below represents a water wave moving from left to right. The time between two consecutive crests is 0.5 seconds. And we can see from our diagram, we are given the direction of motion to the right. And we are given the distance between point B to point F is 6 meters. Now 6.1 says, what type of wave is a water wave? Now we know from our notes that the water wave is a transverse wave. Now remember, we said a transverse wave is a wave in which the particles are in right angles to the motion of the wave. Now 6.2 says write down the amplitude of the wave. Now from here we can see that we've been given the length all the way from down here to the crest up there. Now but we know the distance from the trough to the rest position and from the rest position to the crest is the same. Now that means for our amplitude we have 3 divided by 2 equal to 1.5 meter. Why is it 1.5 meter? Because remember, the amplitude is the maximum displacement from rest position. So all the way from that 0 position up to the crest. Now 6.3 says define the term wavelength. Define the term wavelength. What is wavelength? Wavelength is the distance between two consecutive points that are in phase, right? Then 6.4 says determine the wavelength of the wave. Now from the diagram we can see that we've been given the distance from B to F. But wavelength, the way we know it, is the distance between two consecutive points that are in phase. That means we have to pick 2 points that are in phase. Now if we can start from here, we can see that if we can put a point here, which we can name it K, then we'll have points that are in phase. Remember, a crest to a crest, those points we say that are in phase. But now in order to answer this question, let's try to break it down into segments. Let's cut this into 2. Now we have 2 segments in here. Now let's count the number of segments all the way from B to F. We have 1, 2, 3, 4, 5, 6. Now we can see that we have 6 segments all the way from B to F, but the distance from B to F is 6 meters, meaning each segment has a length of 1 meter. Now remember, we are looking for the wavelength. The wavelength we say is the distance between point B and this point K. As we can see, these 2 points are in phase. Now how many segments are in between B to K? That's 1, 2, 3, 4. So we have 4 segments. That means our wavelength is equals to 4 meters. 6.5 says name 2 points on the waveform above that are in phase. So let's clear all for that. Now we want 2 points that are in phase. Remember, points that are in phase will form a complete wave. So if we choose 2 points, they have to complete a full wave. Now let's take A and E. Now we can see if we move all the way from A up until E, we have a full wave. Also, another way to check that these points are in phase is to check the particle direction. After A, the particles are moving upward, and after E, the particles will also be moving upward. That means that particle A and that means that point A and point E are in phase, right? And they also complete what? A wave. So we have A and E. Also, when we look at D and F, we can see that D is a trough and F is also a trough. And moving from D to F, we can see that we have a complete wave like that. So we can also say that D and F are 2 points that are in phase. Now 6.6 says, calculate the time taken for 4 crests to move past a certain point in the path of the wave. Now if we can check here, we have how many crests? This is 1, 2, 3. But the question is asking us to calculate the time taken for 4 crests to move past a certain point. So what can we do? Let's try to extend this one so that we form a third wave and have the fourth crest here. So how many waves do we have? How many complete waves do we have from B all the way to this point here? Let's name it L. We have 3 waves. So this is 1, 2, and 3, right? Now, in order to calculate that, let's go to the statement above. It says the time between 2 consecutive crests is 0.5 seconds. What does that mean? It means that moving from here, this crest, to this crest here, it takes 0.5 seconds. Also from this crest to this crest there, that's 0.5. Then we move from here to this part, that's 0.5 also. Now the time taken for 4 crests to move past the point is 0.5 multiplied by 3. Now we have 1.5 seconds. 6.7 says calculate the speed of the wave. The speed of the wave. Now understand, to calculate the speed of the wave, we have the formula V is equals to F times the wavelength. Now let's collect our data. We do have our wavelength from 6.4. We said it's 4 meters. But do we have the frequency? We do not have the frequency. But we do know the formula to calculate the frequency. That frequency is equal to 1 over the period. Now what is the period? We said this is the total time taken to complete one full wave or one full cycle. Now remember, they said the time between 2 consecutive crests is 0.5 seconds. Now we know 2 consecutive crests will give you the wavelength because 2 consecutive crests form a wave. Now that means our period is 0.5. So we have 1 divided by 0.5, which gives us 2 hertz. Now that we have 2 hertz, we can come here and calculate. For frequency, we have 2 hertz. And for our wavelength, we have 4 meters. To calculate the speed, simply say 2 times 4. That equals to 8 meters per second. And that's how you could have tackled the question. Awesome.